Limiting reagent worksheet number 1. For this worksheet, what you're going to do is answer the questions as they go. There will be stoichiometry involved like we've been doing the last couple of packets. But the whole idea of a limiting reagent, a reagent is just one of the reactants, one of the things that's reacting in your chemical equation. So let me show you from the reading material what we're talking about here. It says the limiting reagent is the reagent or reactant in a chemical reaction that limits the amount of product that can be formed. And the excess reagent is the one that remains when the reaction stops because there is more of it than you need, so it's in excess. And it says the limiting reagent is completely consumed. So it gives you an example here. If you were making cars and you had 8 car bodies and 48 tires, well, you only need 4 tires per car. So if I have 4 times 8, that's going to be 32. Well, I have more tires than I need. I only need 32 tires and I have 48. So the tires are my excess reagent in this example, whereas the car bodies will limit how many cars I can actually make. So that's the whole idea when you do this in stoichiometry, is that whichever one limits the amount of product that you can make, then that's going to be your limiting reagent. How you do this in stoichiometry, though, is your question will tell you how much of each substance you're reacting, and you'll do 2 stoichiometry problems. So here I'm given 2 grams of ammonia and 4 grams of oxygen, so I start each stoichiometry problem with the amount given, 2 grams of ammonia, 4 grams of oxygen, and I solve for one of the products. In this case, we solve for NO. So notice it goes out and we find out how much NO can be made with 2 grams of NH3 and how much NO can be made with 4 grams of O2. Whichever one gives you the smallest number of, the smallest amount of the product, that is the one that is limiting the reaction, because this is the one that will come out with the smallest. It's like if I look at my cars here, if I have 8 car bodies, I could make 8 full cars. If I have 48 tires, I could make 12 cars. But since I only end up with 8 cars at the end, I know that the 8 car bodies was what limited my reaction. So that's the limiting reagent. So when we do our stoichiometry, whichever one comes up with the smallest amount, then we know that that given was our limiting reagent. And here it is O2 that is the limiting reagent. So if it asked what's the limiting reagent, then it would be O2 as the limiting reagent. It's oxygen. So let's go ahead and do the first set of problems on this worksheet together so that you get the idea of how you're supposed to do it, and then you can do 2 through 4 on your own. So some of them will ask you to balance the equation in this packet, and so we have to balance this equation out. When we do that, we see we have 3 C's on this side, so we need 3 C's on the right hand side as well, and then 8 H's, so I need a 4 here, so that 4 times 2 matches up with that 8. And then let's figure out our O's. We now have 6 here and 4 here, making a total of 10, so I need a 5 to make 5 times 2 is a total of 10. So I've balanced this out. You can put a 1 in front here if you'd like. So now I have my balanced equation, so I know how many moles of each substance would balance out in a reaction. So it tells me I start out with 14.8 grams of C3H8 and 3.44 grams of O2, and I want to know how many grams of H2 are produced. H2O. So here's my H2O. So I'm going to start my 2 stoichiometry problems. Remember, I do 2 of them so I can compare them. So I'm going to start with 14.8 grams of C3H8, and then I'll do another stoichiometry problem here with my 3.44 grams of O2. But let me go ahead and do this one first. So I know that I have to figure out, just like any stoichiometry problem, how many grams would be in 1 mole of C3H8. So I would look at my periodic table, just like we've been doing in the other packets, and I would find the mass of 3 C's and 8 H's. And now, rather than making you guys wait while I show you how to do all of the math in there, I will go ahead and just write it out. So I know that 3 C's would be 12.01 times 3, and then 8 H's would be times 8, and it's 44.097, so I'm going to write that here, 44.097 grams of C3H8 per mole. Then I go and compare my moles to moles like I've been doing in my other equations. Since I have moles of C3H8 on top, I need that on bottom, and I have 1 mole of C3H8 in this equation, and I'm comparing it to how much H2O will be produced. So I have 4 moles of H2O that I'm going to end up with, and moles of H2O on top, so moles of H2O on bottom. 1 mole of H2O is going to be 1.008 times 2 plus 15.999 is 18.015 grams of H2O. So now I'm at grams of H2O, which is what I'm solving for, so I'm going to do 14.8 times 1 times 4 times 18.015, which gives me 1066.488, and that'll be over 44.097 because I'm doing it times 1 times 1. So I divide by 44.097, and I get 24.19 grams of H2O. Now I'm not done because that may or may not have been my limiting reagent. So I also have to do a stoichiometry problem with 3.44 grams of O2. So I start with 3.44 grams of O2, and I'm going to do the exact same thing I did up here with my stoichiometry. 1 mole of O2 would be 15.999 times 2, which is 31.998 grams of O2. And then I have 5 moles of O2 in my reaction, and I'm comparing that again to H2O, so 4 moles H2O. Now since I'm solving for the same product, I don't have to do that math again. I know that 4 moles of H2O will go here, and then 18.015 grams H2O, because I'm solving for H2O, is in 1 mole of H2O. So when you do these 2 stoichiometry problems, the nice thing is you know that these 3 spots will be the same in both problems, and you don't have to redo the math. So now I do these out. 3.44 times 1 is still the same, times 4 times 18.015. And I've got 247.8864 over 31.998 times 5, which gives me 159.99. When I divide those two, 247.8864 divided by my answer is 1.55 grams. And this is obviously much smaller than that amount. So since this is my smaller amount of H2O that was produced, then I know that this is my limiting reagent stoichiometry problem. So it says, which is the limiting reagent? Which reactant created less H2O? And it's O2. So in this case, O2 was the limiting reagent because it ended up making less H2O in our product. And so this is the actual amount of H2O that would be produced. This would not be able to be produced because once you ran out of this 3.44 grams of O2, the reaction would stop. You wouldn't be able to go on with the reaction. Now it says how many grams of the non-limiting reagent are actually used. In other words, the non-limiting reagent is the one that's in excess. So here's our non-limiting reagent. And I know that my O2 is what's going to limit the reaction. So once I run out of O2, the C3H8 will stop reacting. So what I'm going to do, I'm going to use my limiting reagent. Always work your problems. Once you know which one is limiting, always work your problems using this amount because it is the one that will stop the reaction from happening. So I'm going to use my limiting reagent, 3.44 grams of O2, and I'm going to solve for how much of my excess reactant would actually be used. So I plug in my 3.44 grams of O2, which is my given because I'm using the one that will limit my reaction. And I know 1 mole of O2 is 31.998 grams of O2. I know that from here. I know that 5 moles of O2 will react with 1 mole of C3H8, and I know that 1 mole of C3H8 from right here is 44.097 grams of C3H8. So when I do this math, I have 3.44 times 44.097, and I get 151.69368 over 31.998 times 5 I already did up here, which is 159.99. So when I divide, I get 0.948 grams. So this is how much C3H8 would actually react with those 3.44 grams of O2. So now it asks me how many grams of the non-limiting reagent are in excess. So how much is left over? Well, if this is how much was used, and this is how much was given to me in the reaction, then to find out how much of this would be left over when the reaction was done, all I need to do is subtract these two, because I'm going to put this much in there, but only this amount of it will actually react. So I'm going to take my 14.8 and subtract my 0.948, and I get, I should write that down, it is 14.8 grams, excuse me, minus, let me write it again, 14.8 grams minus 0.948 grams. And that'll give me a difference of 13.852 grams. 13.852 grams will be left over. So even though I'm going to put this amount of C3H8 into my reaction and this amount of O2, because this one will run out first, there will still be some of this left over, and that's how much will be left over in the reaction. So yes, you'll get CO2 and H2O, but when the reaction's over, you'll also still have some C3H8 left over that did not get to react because we ran out of the other reactant. You're going to follow the exact same pattern on numbers 2 through 4 here. So part A is going to ask you to do the 2 stoichiometry problems to figure out how much of a certain product is formed. Then part B will ask you which one was the limiting reagent. Part C will ask you to find out how much of the non-limiting reagent was actually used, and then part D will have you subtract to find the amount in excess. So use the example that we just did together to solve 2 through 4, and if you do still have any questions, please make sure you come ask.